Hello, this is Tyler Beamer, Haywood Community College. This is an instructional video for Math 152 in regards to frequency distributions. I'm going to do a My Math Lab or My Stat Lab problem from the Chapter 2, Section 2 homework as an example, and I am working off of the Chapter 2, Section 2 notes in regards to frequency distribution, using this as a resource to kind of guide me through the homework. Alright, so let's take a look at the question I want to do. I'm looking at number 2. It says identify class width, class midpoints, class boundaries for the given frequency distribution. And we have the distribution here of daily low temperatures. These are our specific classes. So we have 40 to 44, 45 to 49, so on and so forth, all the way to 70 to 74. So this is the lower class limit for the first class, 40, and the upper class limit for the first class, 44. The lower class limit for the second class is 45. Upper class limit for the second class is 49, and so on and so forth. So essentially, any data point that falls into the classes gets counted in that class, and that is the frequency. So basically, frequency is how many data points belong to each of the classes that are shown. Okay. So the first question says, what is the class width? So if we go to the notes, take a look at the definition of class width. Class width is the difference between two consecutive lower class limits. Okay, so let's go to our problem. So if we look at the difference between the lower class limits that are consecutive, right? 45 minus 40, that's a difference of 5. 50 minus 45, that's a difference of 5, so on and so forth. So you notice that the difference in the consecutive lower class limits for each of these classes is 5, so therefore that is the class width. And we type that in here, check our answer. Excellent. Okay. Class midpoints. So let's go back to our notes. And the notes have a specific example that goes with it that's different than the problem we're working on, but all of the vocabulary terms and definitions remain the same. This is data from a previous class in regards to height, basically doing a frequency distribution of that data. So let's look at class midpoints. It's the value in the middle of the classes, so basically we find the midpoint of each class. So you add the lower class and upper class limit and divide by 2 to get the class midpoints. So if we do the first class midpoint, we take 40 lower class limit plus 44 the upper class, divide that sum by 2, so 42 is the midpoint of the first class limit. So basically it's just the middle of each class, essentially. And so you can continue to do that. And so you probably notice a pattern that basically if we take the lower class limit and add 2, we get to the midpoint, which should make sense since we have a difference of 4 between 44 and 40 and 49 and 45 and so on and so forth. So that should give us the class midpoints. Okay. And then it says the class boundaries. So let's look at the definition of that. Those are the numbers used to separate the classes, but without gaps created by classes. So if we look at each class, right, there's a gap between the first class and the second class. Right, there's a gap between 44 and 45. There's a gap between 49 and 50, so there's a gap of 1 between each class, and we could technically have data points that fall into that gap. So if you do have a data point that falls in that gap, which class does it belong to? So we essentially use normal rules of rounding to find the class boundaries, and normal rules of rounding is 0.5. Anything that's 0.5 or greater, we round up, which we would round up to the next class, and then anything less than 0.5 would round down to the lower class. Right? So we technically have a class boundary that is below the first class at 39.5. Right? So anything that, or any temperature value that is between 39.5 and 40 would actually round up and get included into this first class. Anything less than 39.5 would not be included in the first class. There's a boundary between the first and second class at 44.5. So, anything that is between 44.0 and 44.5 would go to the first class. Anything that is 44.5 to 45 would go to the second class. So it's a way to include data points that may be in that gap so you can determine which class to put them in. Right? The idea is that basically every data point needs to go somewhere, and you don't want to leave any data point out because of those gaps. And so that's what the class boundary essentially allows you to do. And so every class is going to have a boundary, and I'm essentially take the upper class limit and then add the 0.5 for the normal rules of rounding here. And I even include class boundaries for the first and the last class. So, okay. All right, and that's all parts of this particular problem. So hopefully this video will help you with frequency distribution in regards to class width, class midpoint, and class boundary. All right, have a great day.